starting today. So, all of the far was derivatives. Now we're going to undo derivatives. Now, first we're going to talk about notation. Okay, so ready? Krish is ready. If I have f of x, what do I call the derivative of f of x?
F prime.
Okay, f prime of x. We'll do it with the dy dx's in a second. Okay, then what's the derivative of that called?
dy dx.
F double prime of x. Okay, so as I take derivatives, I'm going to go down. But an antiderivative, you would be going up that list. So let's say you had f double prime. What would the antiderivative be if I cancel out one of them? F prime. Then what would the antiderivative of f prime be? Regular f. Now, you can go one level higher than regular f, and it would be capital F. Okay? So here, now I want you to think about what that means. If capital F is the antiderivative of regular f, then that means that regular f is his derivative. Does that make sense? So if you're going down the list, it's derivatives. What about if you're going up the list, it would be antiderivative. So I'm going to put that on this side. Okay, those are my antiderivative orders. Okay, this is just in your notes. Okay, then if I were to do this with y's and dx's and all that stuff, okay, my regular f would be the same as y. What would the derivative of that be? dy dx. What would the derivative of that be? Yeah, dy squared dx squared. Okay, those are my derivatives going down. Then what's the antiderivative of d squared y dx squared? dy dx. What's the antiderivative of that? Y. And then the antiderivative of that would be capital Y. Okay? So derivatives, you're counting down those lists. Antiderivatives, you're counting up those lists. Now, the first thing that we're going to write is the definition of an antiderivative. Okay, then we'll get into the rules and stuff. But if you know how to take a derivative, today should not be hard, which hopefully most of you know how to take derivatives. Okay, so capital F is an antiderivative for f if capital F prime of x is f of x. Okay, now I want you to think about the list that we just created. That should make sense that if I'm at capital F and I take the derivative, I would be at regular f. Another way for you to think about it is that capital F is an antiderivative, but then if I take the derivative of that, it makes sense that they undo each other and I just get regular f. Because I take the derivative, but then I undo it. Okay. And there's one other definition. We're going to introduce the integral symbol, which is this. Okay, write that down. So this integral symbol is kind of like a really long S. Okay, so this is the integral of f of x with respect to x. So the integral is the long, skinny kind of S, and then the dx is the with respect to x. Now, what if this said dt? Then it would be with respect to t. Or if it was d theta, it would be with respect to theta. So whatever's at the end is just telling you what your variable is. Okay? Now, the rules for these are not super hard. Okay, they're literally the derivative rule, but backwards. So I want you to think about in your mind how to take a derivative. Let's just pretend that it's like still semester 1. What is the derivative of 7x cubed? What would you do? Okay, you'd get 21 by doing what? You times the 3 down, and then you take away 1. So you'd get 7x, or wait, 21, x squared, yeah? Okay, I want you to think about, what if I had this but I wanted to go backwards? I would add 1 here to make it a 3 again, and then instead of multiplying the 7 and the 3, I'd have to divide this by the 3 to undo it. Okay, so let's write out the rule for it. That was just to kind of help you think through it. So this is the power rule. The integral of x to the n dx equals. The first thing that I'm going to do is I'm going to add 1 to the exponent. So instead of being x to the n, it's going to be x to the n plus 1. And then, think about this guy right here that I just scribbled out. I added 1 to get x to the 3, but then what did I do with the 3? I divided it in the front. So you're going to have a 1 over n plus 1. Okay, we'll do several examples. It's not hard. So, first example. Okay, we're going to do 8x to the 3 plus 4x dx. Okay, so the order is you add 1, then you divide. So if I add 1, x to the 3, I increase the power. What is it now? X to the 4. Then I take that 4, and I'm going to divide it with the 8. So what is 8 if I divide by 4? 2 plus, next term. This is a regular x. If I increase the power, now it's an x squared. And then I take that new exponent, the squared, and I divide 4 by 2. So I get a 2. Okay, next I want you to put at the end a plus c. We'll talk about it in a second. For right now, I just want you to put it. Okay, we're going to do one more just like that. So just ignore the c for now. Number 2, we're going to do the integral of 15x squared minus, let's make that an 8x plus 3 dx. Okay, term by term. I increased the power by 1. It was an x squared. Now it's an x cubed. Then I take the new exponent that I just made, and I'm going to divide it into the number in the front. So if it was a 15, divide that by 3. Now it's a 5. Okay, next term, I have an 8x. I'm going to increase the power to be an x squared. Then I have to divide by 2 on the minus 8. What is it now? Minus 4. Now, 3 doesn't have an x. You might say he has 0 x's. So if I increase that by 1, what does he get? Just an x. So it'd be a 3x plus c. So think about, right now, 3 doesn't have 1. Well then, if I give him 1, that counts as increasing it. Okay, now the other part of the rule is after you give him an x, you divide by the exponent. But if it's an x to the 1, 3 divided by 1 stays at 3. Does that make sense? Okay, let's talk about the plus c. Okay, the plus c stands for the constant of integration. And basically, you have to put c there because the constant is unknown. This is what I mean by that. I'll let you write it down first. Okay, remember the rule for an antiderivative. When I take the derivative, or when I take the derivative of the antiderivative, it should look the same. So when I take the derivative of this, what do I get? 8x to the 3, check. When I take the derivative of this, 4x, check. But what would happen if I had a constant here when I took the derivative? It would go away. So the c is standing for whatever the constant would have been that had to go away when I took the derivative. Does that make sense? So you don't know what that number is, but you're putting a c there to show that there could have been a constant. We just don't know. Okay, now look at this one. Check your work. Derivative of 5x3, what do we get? 15x squared. Minus 4x squared gives me a minus 8x. Derivative of 3x gives me a 3. But then there might have been a constant, but when I took the derivative, it would have gone away. So that's basically what the C stands for. Okay? Now, if you have a C in your answer, you are finding what's called the general solution. And the reason that it's called the general solution is because that plus C, you haven't found it yet. Okay, and pretty much for all the examples today, we won't be finding that till tomorrow. Okay? Ready to go to the next example? Okay. You don't? Alright. Next one. Number 3. Okay, so we're going to do the integral of x cubed minus 12x squared plus half x plus 4. And then a dx. Now, the integral and the dx, okay, tell you what to take the antiderivative of. So after you do the rule, they both go away. Just like when you take a derivative, you don't keep the d dx in the front. When you do the antiderivative, these both go away at the same time. Okay, so first term, x to the 3. Increase the power by 1. What do you get? X to the 4. And now I need to divide by 4, but there's no number in the front. Then what's the number in the front? 1, so that'd be a fourth now. Make sense? Okay, next term, increase the power by 1. It's an x2, now it's an x3. Then divide 3 into the negative 12. What do we get here? Negative 4 plus. Okay, 1 half x. Increase the power here. X is now an x squared. And then I have to divide by 2, but I already had a half. What's a half divided by 2? A fourth. Or you could think about your timesing by another half. That'd be fine. Okay, then 4 doesn't have any x's. Then when I increase him to half, he'll have only one x. So it'll be a plus 4x plus c. And that would be your general solution. Make sense? So far, so good? Okay. Next one. We are going to take the integral of 3 over x to the 4 minus 6 over x to the 2 plus 5 over x dx. Okay, and then remember, the integral and the dx are telling you what to take the antiderivative of. So you're looking between those two symbols to do the antiderivative. Now, in order for me to do the antiderivative of that, you're going to have to do a rewrite. So any x's that are on the bottom, how can I adjust their exponent to show that they were on the bottom? Turn it negative. So this is a rewrite, just like we would have done with an antiderivative. So I'll have 3x to the minus 4 minus 6x to the minus 2, and then a plus 5x to the minus 1. Okay, so I do my rewrite to turn it into power so that now I can do the power rule. Now, when you add to negative 4, what do you get? Good. So I'm going to get x to the negative 3 because I added 1. But then I have to divide negative 3 into the 3 that was already there. So what will be in the front now? Negative 1. Good. Next term, x was to the negative 2. Add 1 to that. Now x is to the negative 1. But if I divide negative 1 into the negative 6, what's the number in the front now? Plus 6x to the negative 1. Okay, last term like that. I'm going to add 1 to x to the negative 1. What do I get? X to the 0. Then I have to divide by 0. Can I divide 5 by 0? No, all of math explodes when you do that. Okay, there's a special rule. Okay, here's the rule. Okay, the integral of 1 over x needs to have its very own rule because of what just happened. If I write it as an x to the negative 1, I end up adding 1 and getting 0, then I have to divide by 0, it doesn't work. So which function, remember, a derivative and an antiderivative are just backwards from each other. Which function, when you take the derivative, do you get 1 over x? ln. Then the integral of 1 over x goes back to ln. Okay, so make sure that rule is in your notes. Okay, whenever you have a 1 over x, to go backwards, it must have been an ln x, because ln x gives me 1 over x as the derivative. Okay, so if I have this guy here, my rewrite instead is going to be 5 times 1 over x. And then what's the integral for 1 over x? So it'd be plus 5 ln x plus c. And that would be your answer. Okay, now the one other thing I am going to fix is AP, they wouldn't leave these exponents negative. So that's really a negative 1 over x to the 3. And then that's really a plus 6 over x to the 1. So that would be your answer. So if you start off with multiple x's on the bottom, you do a rewrite. If you have 1 x on the bottom, it's going to be a special ln. Okay. Alright, one more like that, then we'll do a couple examples off your homework together to make sure you got it. Number 5 is going to be the integral of 18 x to the 5 plus 5x plus 9. Make that one cubed, we'll make that one squared, and then a 3. Over x2. Okay, so derivatives, you have like quotient rule, product rule, all these complicated rules. All that you need for this is regular power rule. So what we're going to do first is we're going to take each one of these tops and we're going to divide them all by x squared and do a rewrite. Okay, just like you could have done for derivatives. So my rewrite, keep your integral there. What is 18x5 divided by x2? 18x3. Very good. Does that make sense why? You're just canceling out the extra x's. So if I had 5 x's on top, 2 on bottom, that's really an x3. Okay, next term. I had a 5x squared, but a 5x cubed, but I'm dividing by an x squared. What's left over? 5x. Okay, next term. I had a 9x squared. I'm dividing by x squared. What would be remaining after I reduce? Just a 9. And then for my last one, I had a 3. 3 divided by x squared would be 3x to the negative 2. Why would I not use ln? Because it's not 1 over x, it's 1 over x to a power, so I can power rule. Okay, now let's take the antiderivative. Add 1 to the first term. What's the new power? X to the 4. Then I have to divide 4 onto 18, so that'd be 18 over 4. Now, I'll reduce that in the next step, but for now I'm just going to leave it. Okay, next term, I have 5x. Increase the power on x. What is it now? x2. Then divide 2 into 5. It won't go, so I'm just going to leave it. Next term was a 9. What's the antiderivative of 9? 9x. You just give it an x back. And then for my last one, I add 1 to the negative 2. What's the new power? Negative 1. And then divide into 3. Minus 3 plus c. Now remember, if it's free response, that's good enough. But if it's multiple choice, they're going to bring the x's back down into the bottom and reduce. So 18 over 4, how can that reduce? 9 over 2x4, 5 over 2x squared, 9x, 3 over x plus c. And then remember, that's called your general solution because you don't know what the c is. We'll learn how to find that tomorrow. Make sense? Okay, and then I forgot, we have one other thing we have to cover before we look at your homework. we're going to do the trigs and the e's. Okay? Got that one? Okay. These are going to be your special rules. Okay, snow cone, snow cone. When I take derivatives, I go down. How do I take antiderivatives? You go up. So for example, if I was doing the integral of, let's say, 3 cosine x plus 5. Okay, I'd say, okay, well, I need to be on cosine. Cosine is here. If I wanted a derivative, I would go down, but if I want an antiderivative, I go up. So what is the antiderivative of cosine? Regular sine. So it'd be 3 sine x. Now, what's the antiderivative of plus 5? Plus 5x plus c. Okay, let's do another one, number 2. Let's do the integral of 7 sine x minus 1. And I'm realizing I forgot the dx here, so if you want to squeeze it in to that first one, you can. Okay, find sine on your chart. Sine is positive, that means I'm here, but I have to go up. Where do I end up if I'm at the top and I need to go up? Negative cosine. So I'd be at negative 7 cosine x. What's the integral of minus 1? 1x plus c. So you're basically just using the exact same strategy, you're just going the other direction. Okay, last one like that. Let's do the integral of secant squared theta plus cosine theta d theta. Okay, now think back to when we covered trig. We just have to use all the same rules, but they're backwards. Which function, when I took the derivative, did it give me secant squared? Tangent. So that'd be tan theta. Then what's the antiderivative of cosine theta? Sine theta. Plus c. Make sense? Okay, then your only other special rule has to do with e. What's the derivative of e to the x? Then what about if I do it backwards? What's the antiderivative of e to the x? Still e to the x. Okay, so let's look at your homework. I'm going to give you 3 to try, and then we'll go over them to make sure you got it. Okay, I want you to do number 1, number 2, and number 7. Okay, and 8. 1, 2, 7, 8. Okay, give it a shot. Okay, Wilson, we're doing it, yes? Or did you have trouble finding the room? Did you talk to her? Did you talk to your counselor? Okay, give it a shot. 1, 2, 7, 8. 1, 2, 7, 8. Do you understand what we're doing? This is just like words. Yeah, so like you add 1 first, and then divide into 3. Yeah, so if this is dy dx, the original way that it was. Okay, so look guys, look. It says solve for the general solution for each differential equation. Okay, think about what the instruction is. Differential equation just means you have the derivative. What are you trying to get back to? The original, the general solution. So look, if I'm doing, say, number 2, okay, I'm going to integrate. What's the integral of dy dx called, we said? The derivative would have been that, but I want the antiderivative. Why? Okay, look, think about it like this. Dy dx is the derivative of y. Now I'm undoing the derivative, so it's just regular y. Okay, then on this side, what's your rule say? I have to add 1, then divide. So what would I get?
X4.
Yes, and then 1/4. So I'd add 1 to get the 4, then I divide by 4 on the 1 to get the 1/4. Okay, next one, I have a 2 sine x. Think about your snow cone, snow cone. Okay, if I'm on sine and I need to go up, I'd be at -2 cosine x. Plus what? Okay, you get what you're doing now? So number 1, you have dy dx. How do you get back to regular y? You do an integral. So you put an integral here and an integral here. What's the integral of dy dx called? Regular y. And then on the other side, you're doing the power.
Wait, so how did she
Yes? Times it in, yeah.
Where did she get the
Yeah.
Oh.
Yep. Yeah, because E is the same backwards and forward. You doing this one? So that's a good rewrite, but you still have to take the integrative after. So you divide each one first, and then you do the power. And then e to the x backwards is still e to the x. Because it doesn't change. Plus c. Okay, look at your first one. If you need to check it, see if you got it right.
Yes, sir.
Okay, number 7, what would your rewrite step be? Times it in. Good, to get x. Yeah, you distribute. So it'd be x cubed plus what? 3x.
We always at the C at the end.
Yes, until we learn how to find it, which we'll do tomorrow.
Okay.
Okay, so if my dy dx is really just x cubed plus 3x, what's the antiderivative of that? Careful, 1/4. Remember, you have to add first and then divide by that. Okay, then plus c. And what would the antiderivative of dy dx be called? Y. So remember, when I integrate dy dx, that gives me back to regular y. And then if I take the derivative of this, I should get that. You should. It's homework, you know? Alright, this one, you have to do a rewrite. What is it? Divide each term by x. X cubed minus 2x plus 1 over x. And why do we not take... Yeah, because it's a special ln. So I'm not going to write that as an x to the minus 1. I'm going to use my special rule. So first term would be what? 1/4 x to the 4th minus plus
ln absolute value x plus d.
Good. Okay, number 9, while we're on it, how do you rewrite 1 over cosine? Okay, that's the same as secant squared x. And what's the integral? We just put it in your notes of secant squared. Y equals tan x plus what? C. Good. Now, actually, one other thing I forgot to tell y'all. So your derivative sheet, hopefully you haven't lost it. You know it here? Okay, you can use the other side of it. And then you have all your integral rules. Okay, so what's the integral of 1 over u?
ln absolute value.
What's the integral of secant squared?
Tan u plus c.
Okay, got it?
Yeah.
Yeah, give me 1 sec. Okay, then the integral of cosine, what would it be? Sine, what's the integral of sine? Okay, so but it's the same thing as what was on the front. Okay, so that being said, I'm going to put my sheet back up here. I want you to do 11 and 15.
Do we have to?
Yeah, but I'll put my sheet up here. Okay, ready?
Never.
Nikki, you have the paper? Alright. They're all on the sheet, 11 and 15. Wilson, let's go. Okay, number 11, we're looking for secant squared. What's its antiderivative?
Tan.
Okay, secant squared, antiderivative. Oh, I'm on the wrong side. Huh. Okay, secant squared, the antiderivative is tan theta for number 11. Then what comes after that?
Sign, which is
Negative sign.
positive.
So go up to plus cosine. Okay, so if you didn't get that, you're using your yellow sheet or looking at mine. This would have been tan theta. Okay? Alright, 15. What are you going to be looking for? Secant x tan x. Here goes the yellow sheet. Where's secant x tan x?
I wonder.
One of the ones that is obviously already underlined from the other class group. Okay, integral secant tan, what is it? Secant.
X
Huh? Okay, now look guys, just real quick, these are the chain rule versions. So for example, this says the integral of secant x tan x dx equals secant x. Okay, they changed it to a u just because of chain rule, but it's the same exact thing. Okay, what's the derivative of secant? Where is it? Secant. Secant tan. So then the integral of secant tan goes back to secant. Yeah, because it's the same rules, they're just backwards. Okay? Wow. Okay, then plus 2, what's the antiderivative of that? Good. Got it?
Yes.
Okay, we still have one more thing to add to your notes. We have to do
Friday?
the square roots. Yeah, Friday. Okay. Yeah. This. I explained it really well while you weren't listening. Okay.
No, but I get the gist of it, you know what I'm saying?
Okay, number 6.
Wait,
No.
what?
We have like 2 more examples. Okay. It's gonna be 3 square root x. Guys, well done.
Wait,
I will impeach you.
Wait, what was her?
You'll be the only Mu Alpha Theta president to have ever been impeached.
in office. Francesco president, you good, bro.
Okay. The last other thing we have to talk about is just how to do square roots and cube roots. You've already seen it before, so it should take much less than 5 minutes. Okay, the first thing you would do is a rewrite. How would I rewrite a cubic or a square root of x? That would be 3x to the 1/2. What about my 10 square root x cubed? 10x to the what? 3/2. The power goes on top, the root goes on bottom. Then for my last one, it'd be 4x to the 5/2. But then remember, you're still just adding 1 and then dividing. You just have to do it with fractions. So if I wanted to add 1, I'm going to add 2/2. So what is 1/2 plus 2/2? X to the 3/2. And then if I want to divide by 3/2, I'm going to multiply by its reciprocal. 2/3.
Yes, sir.
Okay? Then from there, yeah, the 3's are going to cross out if you want. You can just leave the 2. Okay, next one. I have 3 halves, but I need to add 2 halves. What is 3 halves plus 2 halves? 5 halves. And when I divide by 5 halves, what do I put in front? 2/5. Okay, we'll do it in a second. Then the last one. Okay, add 5 halves to 2 halves. It'd be x to the 7 halves. Okay, then flip it. 2/7 multiplied by 4. Okay, when you deal with a whole number and a fraction, you just times the tops together, divide by the bottom. So what is 10 times 2 here? 20 divided by 5? That's really a 4. Okay, then 4 times 2, what do I get? 8. 8 can't divide by 7, so you'd leave it. Okay, then from there you'd have to return back to rational form, or radical form, which would be, this would be like x to the 5, and then square rooted. That would be x to the 7, and then square rooted. And then this guy would be 2x to the 3, and then square rooted, plus c. Okay. Last one. We're going to do integral of 8 cubic root x plus 15 cubic root x squared. Last one. You're going to rewrite it first, do the power rule, then rewrite it back. What will my first rewrite step look like? Okay, integral 8x to the 3rd plus 15x to the 2/3. Remember, the power stays on top, the root stays on bottom when you turn it into a fraction. Then from there, when I add 1, I don't want to add 2 halves because that's not the same denominator. I'm going to add 3/3. Because remember, you need it to be like one full unit. So 1/3 plus 3/3, what do you get? 4/3. Then I have to divide by 4/3. That means I'm going to multiply 8 by 3/4. Next term, bless you, I need to add 3/3 to 2/3. How many thirds is that? 2/3 plus 3/3 is x to the 5/3. Then for me to divide by 5/3, I need to multiply 15 by 3/5 plus c. Then for your last step, you would just reduce those constants and then go back to cubic roots. So here, what's 8 times 3? 24 divided by 4, what's left over? 6, and then that's x to the 4th cubic rooted. Next one, what's 15 times 3? 45, right? Divided by 5 is 9. And then x would be to the 5th, and then cubic rooted, plus c. Yeah. Okay.
Is there only 2 more questions?
Yep. Yeah. That's it.
We're done?
Do you want to do one off the homework? Why don't you do 3 and 6, and then we'll check it. If you want, do 3 and 6. What would your rewrite step be on 3? X to the, careful. Oh, you're doing 6. Okay, that's fine. Yeah, that would be a 4/3 plus 5e to the x. And that one would be a 3/2. Those would be your rewrites. Because remember, you have to keep the power on the top and then keep the root on the bottom. Okay, we'll do more of this tomorrow though. So.